All right, so we're recording here, and so my name is Noah Gift, and I'm writing a book right now for O'Reilly, a second MLOps book. This one is called Enterprise MLOps. The one before was called Practical MLOps. And one of the things I'm doing is interviewing people that are, related to the MLOps space. And I have a couple of people that are doing machine learning engineering and making tools around that. Pedro and Javier. And do you want to introduce yourself? Who wants to go first?
I can go first.
Okay.
It's good. So hi everyone. I'm Javier Luraschi, and I've been a software engineer. So not really a data scientist, not really an AI expert, but a software engineer that has been building AI tools, data tools for almost 20 years. So even though my formation was not in data science, I studied mathematics and computer science back in the day. And then I basically have been specialized in building, tools for back in the day, tools like Office Access, which was a database. And then I work on deep learning, on Microsoft Research, Spark. And more recently, RStudio, I developed a bunch of packages there. I work with Databricks on MLflow, which is, your topic, MLOps framework. And since then, we'll jump into what we're doing right now, but that's kind of my background, and thanks for having us.
Great. How about you, Pedro?
Sure. I'm not an AI expert, nor a data scientist either. My background is mainly in robotics. I studied robotics and philosophy. And for the last 10 years, I've been an entrepreneur. I created two companies, one about robotics and the other one about educational technology. And here my role at Hal9 is more on the business side, business development, fundraising, and lately hearing a lot of potential customers and understand the need and the problem that we're trying to solve.
Great. And maybe then I guess we could just go right into it. And I think you were going to go right, Javier, and just talk a little bit about what you're building and maybe do some demos.
Yeah, no, for sure. Let me start by sharing my screen. Oh, I might need, I can't share my screen. I might need to get, all right. But if you give me another shot, now I can share it. That looks great. And you can see my screen, right?
Yes.
Yeah, so I won't do the full presentation, but we have some slides. And I think if we go really fast, it might actually explain what we're interested in and what's the problem that we're trying to solve. And honestly, I think that's the biggest takeaway. Like if I could communicate something, I would want to communicate kind of like my passion for the space, and then we can show exactly what we're building for those that are interested. But yeah, we'll give you the background. So in general, if this were to be a proper talk, we would talk about artificial intelligence with web technologies, and specifically JavaScript. And I'll just give you like a quick overview of why that's interesting. And one of the reasons why I became passionate about JavaScript, it's twofold. One, I was in RStudio building packages, and at some point the company shifted to not only do R packages but also Python packages. And then at the time I had this this problem of figuring out, do I build the package on R or do I build it on Python? Because both are pretty decent programming languages, but they're not very interoperable between the two of them. So if you build something for R, the Python package ends up being subpar. And if you build something in Python, the R package ends up being subpar. So what I found out is that JavaScript could be a pretty good option for kind of like being in the middle of that. Anyways, so then that create opened up my curiosity, and I started looking at what's out there in the space of JavaScript and data science. And I found out one community called Tensorflow community that basically ported the TensorFlow framework, which your students and listeners might be familiar with. It's an AI framework, and they ported it to JavaScript. And someone built a demo of a self-driving car built completely in JavaScript. Now, I mean, obviously this is just a demo, right? And you can criticize it, but to me, what is it really interesting is that this demo runs completely in JavaScript using things like Tensorflow.js, using the GPU of your browser through WebGL, and that opened up kind of like the passion to explore this space. And then I found out, if your listeners might be interested to check out, in Twitter, there's a hashtag called #MadeWithTFJS. Mostly it's a community of people that have been building, data science, AI projects with JavaScript. And I know these are some of the demos, right? So one built the American Sign Language with the webcam, and you can, like control and, interpret, using only your hands. Some people build avatars, like the one we have on the bottom right. And someone built, her name is Charlie Gerard, and she built like a 3D frame using an iPad, right? So the way it works is the browser uses Tensorflow.js, recognizes your face. Then you do the backwards projection of the camera, where the subject is, and then you fake the 3D, right? But the cool thing is that it looks 3D when it's not. Anyways, so there's a community of people that are a bit of rebels that are doing JavaScript, data science and AI with JavaScript, and it looked very compelling. So the next part was for us figuring out what to build in that space, and I'll get into that in a second. But just to give an overview for those that might not stay for the whole talk, basically what we're doing is we're starting to build a platform for data science based on JavaScript. And when you do data science, one of the very first things that you need to do is a linear regression. So just to get at a quick demo, and then we might come back to this. Basically, we build this linear regression using, let me just refresh this. And yeah, so we build this linear regression all just using web technologies. So the way that it works is, first of all, one of the really cool things is that, first of all, anyone can make use of it. So we believe that is very accessible to anyone that might be interested in, learning JavaScript, data science, and AI. And the other one is that it's very interactive. So here we have the regression, and then we can very easily change the parameters of the regression. And it's actually training in real time. As you drag the slider, you can change, what type of regression it is, etc. So, and really what the product does, and we can get into more details of that, is it leverages web technologies and other technologies like Python and R, but it's very focused on web technologies, and it uses libraries like Tensorflow.js or Kero to build this. Anyways, yeah, that's just a quick overview of our company and what we're doing. This is completely out of date, so I'm going to show you more. One thing that I learned is that companies move super fast, and whatever you do like the previous week, the next week is completely different. So this is a better overview of our company. We have 12 people working in Hal9. Myself and Pedro are co-founders, and we have a group of data scientists that are advising us or working with us full-time, like Kevin and Shir and Brenda, and a bunch of engineers that are working with us, and Gatlin Laborde as an advisor, which happens to be the case. If you want to learn more about TensorFlow, O'Reilly, if you want to learn more about all these topics and Gantt as well, like there's a book from by Gatlin Laborde and O'Reilly called TensorFlow.js. JavaScript, what is the name? I'm trying to remember. Artificial intelligence with TensorFlow, I believe. We'll see. Wow, my internet connection is super slow. Yeah, but I'll show the slide later on. So we have Gantt, we have a bunch of advisors. And anyways, so that's the overview of the company. But then, really the question I think that your listeners are having, and feel free to interrupt me with questions, is, like, why JavaScript, right? I mean, and I don't know how interactive you want to do this, Noah, but
yeah. I mean, I could ask, like, so I taught a class for several years at Northwestern, actually, where one of the things that we did was do applied computer vision.
Mm-hmm.
And the focus of it was to not write much code at all, to try to not write any code.
Yep.
And many of the tools we used were things like TensorFlow.js,
yep.
or used, Google has the AutoML that can go to a TensorFlow Lite model, and then you take the TensorFlow model and you put it to your phone or whatever. So that style of like no code or low code computer vision or machine learning is definitely something that I've had a lot of experience with, and I actually believe in. So I think that part of it, I think, is a very interesting idea.
Yeah, and like you, we fell in love with the community and the technology, and to us, really the big struggle was, who needs this technology, exactly why, and when does it make sense, right? And that's the thing that we've been struggling with for the past, honestly, like year, since we started, because obviously there's potential there. it's a very powerful technology, but it's like, okay, exactly when do we use this? How, who's the user, why? And, if you indulge me in going for a couple more slides is, really the question is like, if we talk about, data science or AI with JavaScript is like, why, right? Like, I mean, we already have Python, we already have all these programming languages, right? And just thinking about them, when we think about the programming languages, first of all, Python, what I want to mention is that the languages that we have today were not designed necessarily for data science. So if you look at Python, it was a generic programming language creating by Guido, right? Van Rossum. If you look at R is interesting because it was actually created for data science, right? For computation and statistics. And even though it was created with that purpose, the reality is that Python today, it's like a broader community, right? So it doesn't really, the life of a programming language is pretty chaotic, right?
Yeah, and I agree with you. I think Python, I've been doing Python for well over 20 years, like 22, 23 years. And Python was built before the internet existed.
Yeah.
Right. So it was like people were doing FTP uploads.
Mm-hmm.
They weren't using like, a website somewhere. And so it wasn't built to be distributed. Like the concept of multi-core machines wasn't really something on anybody's mind.
Mm-hmm.
And in addition, with Python, they really have no story for data science unless you use something like NumPy or Pandas, and then it's almost a different language.
Yeah,
Yeah.
And you would probably agree that one of the, here we're just talking about programming languages in general, but the other part on top of the programming language is the community and the packages, right? Because that's really, honestly, Python might not be even as important as a programming language, but the Python community that build the packages,
exactly, yeah,
like that's super powerful, right? And so, but
and
yeah,
then
I mean,
and then R too, like R was in New Zealand, I believe, right? And was originally from stats professors in.
Yes, correct.
Yeah, I lived in New Zealand for a year, and I've met some R people, and that also has, there's lots of great things about it in the community and everything, but then, if academic computer scientists built the language. So to your point, I agree with you, like both Python and R have issues that if you were starting from today, you probably would do something very different.
Yeah, and it's, I think that's a great point because, one of the great programming languages out there is Julia, right? And Julia is a great programming language. I know that, people in DeepMind, are using it. And it's kind of like, hey, if we were to start from scratch, like how would the language look like? It would be performant, clean, all these things. But also, this is not a criticism to Julia, but, the community behind Julia is not yet at a par with either R or Python. So it's kind of like one of these weird things where you could have the perfect programming language, but if you don't have the perfect community behind it, then things still don't align. And I'm still very optimistic for Julia, but it's kind of like early to tell, right? Like it needs a few years. As you mentioned, Python is more than 20 years old, so maybe in 10 years Julia is going to be the programming language. But it's kind of like they're the couple, the language and the community. You can have, I guess the best thing would be to have a great language with a great community. But sometimes it just, I don't know why, like someone will have to research this, but sometimes that doesn't happen. That's fine. Yeah, and then coming back along with JavaScript, right? JavaScript is kind of like so old and so ubiquitous that I couldn't find a definition of what is JavaScript. The closest thing that I found is, an article for Computer World in 2008. When we know where JavaScript came from, right? Like from Netflix, from Netscape, and it evolved from as a language for the web browser. But like I couldn't even find like a proper definition of what was the goal, right? But one of the early articles described it as a glue language for web designers and part-time programmers to that were building the web, right? So honestly, like one of those languages that kind of like started out of necessity because Java was already there and it was the cool programming language to use, but like it was not available on the browser. So someone hacked it together, right? And it has been evolving for a really long time. And I have like a bit of a joke here for you that you might, sorry, actually, before I get there. Well, anyways, I'll get back to the joke in a second, but back to community, right? Like if we look at the community around JavaScript. It happens to be the most popular programming language in the world, followed by HTML and CSS, which, you could argue that it's also JavaScript and web technologies in general. And then, followed by SQL and Python. So obviously today, there's no big community whatsoever on data science around JavaScript and web technologies, but the community, around web technologies, it's huge, right? Like basically it's probably, this is just a wild guess, but it's probably at least 5 times, if not 10 times bigger than the data science community, right? Just because, we have a lot of web developers, backend developers. So it's one of those things that, even though the programming language might not be ideal, the community is behind it, right? And going back to the joke, you probably have seen this video, and I won't show it all because it's not needed, but it's just it's people basically making fun of JavaScript in general. Like is what happens if you add an array plus an array, you get nothing, an array plus a dictionary, and then you get don't remember exactly, I'm just letting the video play, but it's what is that? It's an object, right? So it has a lot of inconsistencies, and I think then the next joke is you add a dictionary and a dictionary, and I can click here a little bit faster. Or sorry, the other way around. You would expect the same, right? Because that would be a nice property to have, but no. If you add those two, you get 0, and then if you add, it's just ridiculous, right? And if you add an object and an object, I don't remember. I didn't rehearse these jokes, so hopefully it's not going too poorly. But if we do a dictionary and a dictionary, then what we get is not a number, right? So that obviously doesn't make any sense. And every programming language has their like their blind spots, and it's not perfect. So this is to me to say this talk and this discussion is not about like, hey, JavaScript is great. It's like, no, it's like JavaScript has a bunch of problems, like and probably worse than other programming languages in many ways. But also, if you go back to this topic, right, it's like a super popular programming language, and it's everywhere, right? So I don't know if you have thoughts there, Noah, or if you agree or comments.
Yeah, I mean, I think what happens with technology is that the best technology is never the solution that's picked. It's always the popular technology, and if you try to only pick the best technology, you're going to be very frustrated. So after a while, you have to pick the most popular.
Yeah, we have this joke in the startup community, which Pedro knows better about. Maybe you should comment about this, Pedro. But like, like the joke is that when you're doing a startup, you never want to start with a new technology. You want a robust technology that works, and right, and you don't want to spend time messing around with things. And Pedro, I don't know if you want to add a comment, because you're more of an expert on entrepreneurship than me.
Yeah, I mean, it's a difference of incremental innovation and leapfrogging to something new. It's not bad to use proven technologies, but if you want to move forward and to leapfrog, it makes sense to do things that sometimes sound like against the state of the art.
No, completely agree.
Yeah, I've run startups myself, and I would say the biggest mistake I made was being too creative in picking technologies. I'd say if I had to do everything over again, always pick the boring technology. That's just me.
No, it makes a ton of sense. And in our case, we mentioned things like Tensorflow.js, right? I mean, that's the new technology that we're playing with, right? And you really
kind of boring too, because it's
it's already there.
It's exactly, and it works with JavaScript, which is the most popular. Yeah,
that's true. That is true. And then I think this might be honestly the most interesting part of this talk, which is like, why JavaScript, right? I mean, we already criticized JavaScript a little bit. We also saw the good parts about JavaScript. Like, what is the problem that we think that might be interesting to solve in general? And right now, one of the big problems with AI, and I think you probably are aware of this, is like the whole MLOps ecosystem, right? Like, and really it comes down to this: like, you build something that is AI related, and it could be something as simple as a linear regression, all the way to a deep learning model with like autoencoders or whatever, right? And and the problem is, like, once you have that working in your local machine, like, how do you actually build that web application, or like an API or a service that scales to millions of people, or or at least not to millions of people, but at least that doesn't go down and doesn't get overloaded when two people are using the application. And like this, I'm sure that your listeners have already know about this space, and you probably have other content that, like explores the MLOps space. But, I think, we'd love to hear your thoughts, but, like in general, I think I think we can all agree that, operationalizing AI is pretty hard. And, like we're creating all these new, stack called MLOps. I put on the bottom right, like the chart of Google Trends on MLOps, and it's just going parabolic, right? Because, AI got developed, and then now we need to actually make it usable and, like reliable and consistent. So I'm sure that this is like a whole new topic, but there's a big, there's a big problem to be solved here. And one of the things that we identified is that always frustrated me while I was in our studio is that data scientists build something in whatever language, Python, R, whatever. And then once it actually becomes a customer application on the company, it usually gets rewritten almost completely, right? Like you tear apart like the APIs, the front end, you move it to like, web technologies. If it's a mobile application, React Native. If you're like a, like a Java enterprise company, then you move the API to Java. And it's just like this very messy world that, we haven't figured out. And, what's your take here, Noah? Because I'm pretty sure you know more about this than us.
Yeah, I mean, I think that the deploying the system is the priority, because in the case of I was just writing actually about this a week ago in the book I'm writing, that the book Good to Great by Jim Collins, he covers a bunch of research on like what were the things that made I think it was Fortune 500 companies, go from good to great. And one of them is that they had a good use of technology, but that the technology wasn't the thing that created the value. The technology was the thing that accelerated the value. And so many companies, they're not doing like Kaggle. They're not doing, from scratch, very complicated training, billion parameter, neural networks and things like that. What they're doing is they're trying to solve a business problem. And so any tool that can fit in the scope of helping someone accelerate their momentum in their company, I think is the right approach. And so, yeah, I think starting almost at the end, or, like production first mentality, is what people should be doing. And I think they weren't doing it. Yeah. And that's why there's been a lot of data scientists actually fired, because they haven't delivered anything. It's not necessarily their fault. It's that there was a mismatch where the executives in the company said, we want to hire data scientists. And then they're like, well, the data scientists come, okay, what do we do? And they're like, well, we don't know. What should you do? Then that's not really an effective use of technology versus here's our core advantage, whatever it is. We can, I don't know, sell books if you're Amazon, or, sell iPads if you're Apple. Okay, well, how do we sell more? Right.
Yeah.
Well, we can use AI.
Yeah. And I 100% agree with you. I think that's right on point. It's, just to quote Elon Musk, right? Because, he's always controversial, and, that he the way that he explains sometimes Tesla is that making one car is pretty easy, right? You make one and it's like, cool, it's a prototype. But creating a factory that actually produces them, like on scale and, reliable and all these things, it's like, that's a really hard thing. I think that he might give too much credit, but like, I think he's on the right direction that, building a prototype is easy. Like building a system that doesn't fall apart and, like is reliable and consistent is really, really hard. So I think, I think that is definitely correct. I think perhaps the more controversial part that we are, not proposing because other people have already identified, but that we identified ourselves with that community is that, well, what if we look at the target technologies that are good at deploying stuff, and we do data science there, and you probably know where that's going, because if you look at where JavaScript lives, well, and what JavaScript can do, and not just JavaScript really, it's web technologies, right? Because you can think, a lot of people don't like JavaScript, but they really love TypeScript. That's fine, right? Like it's a superset, or when I say JavaScript, I try to be, I try to be controversial. It's really web technologies, but yes, in general. So where are web technologies being used? They're being used on the browser, and one of the things that is crazy, when you think about deployment, is that every person in the world that has access to a computer most likely runs, a browser, and that browser has almost like a full integrated development environment, right? With a profiler, with a memory manager, with dependencies, like it's just there, right? I mean, people don't know it, but you can go you can go to your browser, do right click, inspect element, and you have like a full development environment just there, right? And it's everywhere. And that to me alone, like I could finish this, that topic here and be like, yeah, game over. It's like everyone is the programming environment that every device has in every part of the world. And that's really powerful, but that's just the start. If you look at where else is the browser, is like, well, people have been creating browser applications. So for instance, Slack and RStudio are built on top of web technologies like JavaScript, right? And people also don't know that, right? Like you use a Slack and you think that is a desktop application, but it's not. It's an actual HTML page with JavaScript that is running on the background. And Google pushed it a little bit even further, making web technologies the operating system with Chrome OS. I don't know what's their adoption today, but nonetheless interesting. There is Node.js in the server, which is a server-side browser. A server-side framework for building server applications, and it runs JavaScript or TypeScript or whatever version of the web technology you're using. And it's actually, yeah.
Well, I was going to say that with your point about the web-based development environment, that I mean, I've been using Linux for 30 years. I mean, like mainframes, Solaris, all kinds of, I've seen pretty much everything from the beginning, and I don't use my machines anymore. I just use a web browser. So I use either GitHub Codespaces, or I use AWS Cloud9 or some kind of cloud shell. And I tell students to do this as well. Like, why would you use your desktop? It's actually going to be much slower. So I agree with you that personally, I only want to develop inside of a web browser.
Yeah, no, that's a great point. And it's even worse than that. Like if you have told, back in the early days of JavaScript, hey, we're going to be running the servers on JavaScript, they would be like, no, that's insane, right? It's like, we used to be writing CGI with like, basically native code on C++ to like run all these things. Like we would never have thought that JavaScript would be run on the server, right? And take over such a big space. And in general, like there have been companies that are, serving millions of users. I think it might have been Netflix, the company that introduced kind of like may popularize the concept of microservices, many of them running in Node.js at very small functions. So anyways, this could be another whole talk, but it's just to give credit to JavaScript and its rise. One of the demos that I like showing is like running WebGL in the browser, which is it's a version of OpenGL running on the browser, compatible with JavaScript, and you can look at this 3D city all in the browser. And when you look at Python or you look at R or Julia, it's like still like like the best visualizations are built with with web technologies, right? And they integrate them and they use them, etc. And then just for fun, I won't open this link, but someone built compiled a version of Doom, not necessarily to JavaScript, but just as a brief overview. JavaScript, the people at Mozilla created something called well, not Watson was the the culmination, but they created a optimized version of set of instructions for JavaScript that then became WebAssembly. And people have been compiling stuff to WebAssembly, which is pretty much hyper optimized JavaScript, almost bytecode, and you can play things like Doom, right? And more recently, there is a Pyodide project that allows you to run Python on the browser, right? And people are just pushing the envelope on this space, and it's just I don't think I have a slide for web development. I have one even for microcontrollers, but if you think about for mobile development, many of the mobile applications are actually built with React Native, which again, it's a version of HTML and JavaScript that uses the React framework for compiling native components. So it's we could go on and on. And so going back to deployment, basically the question is, if you're going to build data science or AI solutions, do you want to solve the deployment problem, or do you rather go and say like, what, I'm just gonna write my model, convert it to Tensorflow.js, or just start with Tensorflow.js, and then you can deploy your data science applications wherever you want, right? And I think right now people are a little bit shy from this because it's kind of like too early, but that's also an opportunity to have people in the community that really step up and like become the next author of pandas for JavaScript, right? Or the next Hadley Wickham from their community for JavaScript, right? Like there's just a lot of opportunity to to build those technologies into JavaScript. Yeah. But yeah, I don't know. Do you have any thoughts about,
Yeah,
deployment
I
in
mean, I
JavaScript?
think I think I have used Node in production
Yeah.
in like large scale companies. There was a logging company I worked at where we used Node, and it's very performant. I mean, it is faster than Python, and I do agree with you that the idea of being able to have a deep integration with clients and server all in the same language, there's some benefits to that. And yeah, to your point about the community, it would be interesting if there was like a library that was able to do work with data frames and work with some of the things that we see with with these other languages.
Yeah, no, let's get to that, because usually I like to talk a little bit about what is artificial intelligence, but I'm going to skip all this because your audience, I think we can assume that they've listened to some of your other talks, etc. But I would just say that in general, when I think about AI projects, machine learning projects, data science project, this is what comes to mind. And I partially borrowed this from Hadley Wickham's data science with R book, which any data science book, any machine learning book, in one way or another one, maybe some of the steps get combined. But in general, we all agree that there's some data, you import it, you transform it, you visualize it, you train, you predict, you explain, and you export, right? And I'm sure this is something that you've covered at but then the really interesting question is okay, what happened, how do we do these previous steps with actual JavaScript, right? And I'm going to refer your listeners, if they can go to Hal9 news, or maybe we can put the link on the content that you have.
Yeah, I can put when I upload this, we can put it as a link.
That makes sense, because after investing in this literally almost a year, just exploring this space, we put together a blog post just with our findings. But I'm going to walk you through them, and we can discuss them. But if someone prefers kind of like a reference, like this would be the blog post that is worth. I mean, it's not that big, and basically it goes through the points that we're gonna cover right now. But yeah, so the interesting thing is okay, how do we do each of those steps with JavaScript? And the question is really, does JavaScript even make sense, right? Because maybe we're just wasting our time, right? And a spoiler alert, probably not. But when we look at visualizations, to me, like one of the craziest things is that the New York Times, and you probably already know this, right? And many other communication organizations that are very relevant in the world, they actually don't use Python or R or Julia to build those visualizations. They use JavaScript, and specifically they use a JavaScript library called D3, right? And there's other libraries, but so in general, when I think about data visualizations and can JavaScript do visualizations, my answer is it's not even a resound yes, it's like an absolutely yes, right? I mean, it is almost like the most powerful tool to do super interactive, amazing, eye-popping visualizations. I'm not an expert on visualizations. You should definitely have someone, as part of these series to just talk about D3. But it is one of those tools that it's super amazing, and it's pretty awesome, right? I don't know if you have thoughts there, but
yeah, I mean, I agree with you that the less steps in between, the better. And in fact, there was a period of time where there was all these web frameworks, like Ruby on Rails, Django. And honestly, a lot of that doesn't even make sense, because why would you take some data from the web browser, serialize it, and then throw it back to some, really inefficient language that's running on the server, do some stuff to the database, then come back? I mean, the single page app, I think, which I think some people may know about, where you just put some JavaScript in a CDN somewhere, and then the browser loads it, is just way more efficient. And for visualization, you're just gonna have a lower latency.
Yeah, no, for sure. I'll show you a demo of that. Maybe I can I'll do the demos at the end, because I honestly don't want this to be advertising. I'm sure that if people are interested in what we're doing at hal9.com, they'll go to the site and explore it. But we'll get to that. I think I'm more interested to get the message out of hey, if you're into data, you should definitely try out JavaScript and the community, etc. But yeah, and then there's a couple other projects. We really like the observable plot library created by Mike Bostock, who is also the creator of D3. But there's another 20 awesome libraries to do plotting in JavaScript. So no need to talk there too much. But I think a more interesting topic is, okay, cool, we have visualization, but how do you transform data, right? And you ask the question, what data frame do you use? And honestly, just to be very upfront, we're still figuring out, right, on the JavaScript community, but there are options, right? And the ones that we have identified that we like, first of all, D3, and D3 is not a data frame library, but Mike Bostock, with good reason, and I think the JavaScript community, they basically popularized using an array of dictionaries for representing a data frame. Now, if you're familiar with data frames, you will probably already figure out that this is not the most efficient representation, but like it works really well. It's intuitive. You put the things there and it works, right? So there's D3, TidyJS, Arrow, and Danfo that we really like. So TidyJS is a port from the TidyR library on the R community by Hadley Wickham. And it's a really nice port, and you can see it, you can use it, and it's, again, this library uses an array of dictionaries to transform the data, which is compatible with D3. And we've seen that you can process up to like 100,000 rows with an array of dictionaries, which is not terrible. Like many data sets are on that ballpark, and it's intuitive. So nothing wrong with this whatsoever.
And with TidyJS, is there like a size that's a sweet spot where like if you get to a certain data size, like with pandas, maybe over a gig and you're in trouble?
Yeah. In terms of size, I would say somewhere around like 10, 50 megabytes. Like it's it's pretty small, right? But if you look at data visualization and applications, like that's still a lot. But definitely. So just to give you a little bit of background, right now we're discussing like the different tools, in just the order slide, but the order of the slides actually matches what we did in the company. On the open source project that we're developing is like we first tried TidyJS and D3 and then TidyJS, and we love it. But then as we build more complex applications, we were like, oh, it's like, like this doesn't work, right? And that doesn't mean that it's bad, but like it's just part of learning and understanding what's out there. So really size was the reason why we left TidyJS. That doesn't mean that it's a bad tool. It just means it's actually a really easy to use tool. It just if your data set is around there, that's what you want to use. The next tool that we explore is called Arquero, which is a tool from the University of Washington, and their creator works also on Trifecta. He's one of the founders actually of Trifecta. And anyway, so the big change with Arquero is that it's a columnar store, right? So it's a dictionary of arrays where the array is a column, right? And if you're familiar with how data frames are structured and all these things, that's how Pandas works. That's how the base R library works. That's how dplyr works, etc. So that makes a ton of sense. And actually, we've been able to deal with million plus records. I think a million is already like if the size were still comfortable, but you're kind of like on the warning zone. I think Anshid, who works with us at Hal9, did a demo with 3 million. And if you have a bigger computer and whatever, you can go a bit bigger. But like a million records is like pretty decent size. So that's something to mention. And then another interesting library, which honestly we investigated like 6 months ago. So 6 months ago, it's like light years in when you're looking at new technologies. So Danfo was a little bit early stage for us, but basically the really cool thing about Danfo is it's a data frame library based on GPUs through Tensorflow.js. So we'll talk about Tensorflow.js in a second, but basically, you can load the data frame in the GPU by using Tensorflow.js, and then you can do transformations and etc. The caveat was that it was a little bit early, and the library was not mature when we took a look at it. But I almost want to say that it's, by the time today, like it's probably in a way different place. The author, I believe his name is Rising Odawa, or might be I don't want to quote the wrong name, but Rising Odawa is the co-author of this library. He's like a pretty awesome person, and he actually rewrote it on the last 3 months, and it's looking pretty great. But anyways, I'll just mention it here. So and this again to try to explain, hey, there's definitely a few libraries out there. And one of the ones that I'm missing to add to the slides, there's a backend database called DocDB. I don't know if you're familiar with that one, Noah. And someone actually compiled DocDB to WebAssembly running in JavaScript. And they have an insane demo where I think they're querying something like 1 terabyte with one trick, right? Like, so the trick is you need to index the data as Parquet files on the server before you query them, right? So you're not really processing 1 terabyte. You have 1 terabyte on the server with a very smart index that when you ask for subset of the data, you're only fetching bits and pieces. But then, like, since everything is efficient and they're using protobuf, like, you can deal with large amounts of data. Again, not all the operations work. Like, it's, to me, like, honestly, my argument is not to say, hey, you should ditch Python or R, but it's more about, like, look at what's happening on the web community, because this is insane, right? Like, if you look at the progress that is being made, I'm like, guys, like, we should pay attention, because it's moving in a really, really interesting direction. But anyways, so those are data frames. And the next one, it's a pretty we can go through this one pretty fast. Importing data is honestly one of those topics that is super boring. But if you ask the question, can you do data import on JavaScript? It's like, probably yes, and probably even better than Python and R and Julia, right? Because it's just calling APIs and loading, different data formats, right? Like, we're working with a customer that has like a super weird, like a file format. I won't mention it because, like, I promise, their project is it's secret. But, like, all the weird file formats that you can think of, there's more likely to be a JavaScript, like a web reader than, like, anyway. So data import, like, super high class, first class. Most of the API examples to connect to services are REST APIs with web endpoints and JavaScript endpoints. So, like, I get like 100 out of 100, right? On import, 100 out of 100 in visualizations, and in transformations, maybe like 70 or 60 out of 100. But anyways, and then when you think about exporting, right, which is about communicating, doing reporting, is like, again, like, JavaScript gets 100 out of 100, right? Because you cannot only build HTML reports, but you can also build web applications with Vue, React, HTML. Like, you have like a breadth, like a super broad a range of tools that were designed with communication and for information communication in mind. Now the caveat is that, well, I'm a data scientist and I don't use those tools, and that's a fair argument, but that's not the problem of the technology, right? Like, that's like a mindset, skills type of thing that like we can get better at. So yeah, like, I don't know if you have thoughts here, but to me, these two things are pretty great. Yeah.
Well, there's just I mean, yeah, again, back to the latency. If you're going to visualize in the browser and you don't have to talk to anything else but the browser, then you don't have to go back and forth and deserialize all this information with some server side web framework.
Yeah, no, that's awesome. Yeah, I completely agree. And this is really the tricky one. This is like where where the most help is needed, and like, it's a topic that we need to talk about, right? It's like, okay, that's all awesome, right? But, like, what about my linear regressions? What about deep learning? What about actually training data science models, right? And we know that data preparation is 80% and communication, all that, but that 20% of data science, of actually building the model, you still need it, right? And the good news is that there's a few projects out there, and I'm missing some that I can refer to, but the big ones is there's a project called ML5, and the one that we're really focused is Tensorflow.js, and really Tensorflow.js, I think, is the life-changing project that really makes this possible. Otherwise, you might be like, well, like, this is pretty awesome, but if I cannot train, like, that's a no-brainer, right? And just a little bit of background of Tensorflow.js. TensorFlow was a project that started in Google as part of them working with GPUs and like optimizing CUDA libraries, and then it got ported by to JavaScript, and the Google team adopted it. And like, this is the official TensorFlow blog post. Just a few years. Well, talking back on stable technologies. This is 2008. So to me, like, all those 4 years that we've covered, like, it's a pretty mature technology by now, but still pretty new if we compare it with everything else, right? That we discussed. So yeah, I mean, that's the library, and like, the really cool thing is that you can there's real super high-end applications that are happening on TensorFlow.js, right? And when we think about training, and doing machine learning models, we usually think about tabular data frames, like all these things that like we've been doing for many years. Like, the demos that people are building with TensorFlow.js are like, computer vision, music, audio processing, like all these, very high-end like state-of-the-art like areas of research, NLP, right, that are happening, that are super interesting. And just to give you a quick demo on that with what we're doing at Hal9, and hopefully I'll find it really fast. Let's click here. One of the applications that we built is we built a sentiment analysis tool, pipeline with Hal9, and I haven't even explained what is Hal9, but like I'll just show demos. Basically, it takes data from Reddit, and then what we're doing is we're doing sentiment analysis. And the cool thing is that this sentiment analysis is running again in TensorFlow, right? So you see the JavaScript code, you see like here we're loading TensorFlow and then just doing sentiment analysis, and all of this is like something that would take a lot of time to do in other tools, and we'll get into what we're doing, but it's possible today, right? So yeah, definitely check out Tensorflow.js, made with Tensorflow.js in Twitter, but like the demos are super awesome and they're really fun. So yeah, definitely.
And what about pre-trained models as well?
Yeah, so they have a library on GitHub, of pre-trained models. And they're pretty great. So you can just include if you want to do post estimation, for 3D recognition, or if you want to do sentiment analysis, like on the demo that I mentioned, like I didn't do the training. I actually used one of the pre-trained models, which is really
like
awesome.
on TF Hub, I think.
Yeah, TF Hub. Yep, you're right.
They have a lot of TensorFlow.js.
Yep.
Yeah, I think I agree with you. Like the kind of demos you see with TensorFlow.js are so much deeper than demos you would see in another language.
Yeah, no, for sure. And one of the things that it's also possible to do is you can train a TensorFlow.js model in the server on Node.js using a GPU if you have to, right? So and again, it's one of those things that we're learning how to do, and there's not that many resources, but like the technology is there, and if you're motivated enough, you can do it. And one of the things that we're trying to do at Hal9 is make that simpler, because it's still it's a little bit tricky, but like the technology is there, and you can run Node.js and connect your GPU, and you get GPU training performance while training the models as well. But yeah. And just as a quick overview, because we're running also out of time, and I want to show you what we're building. But if you want to learn kind of like how to use TensorFlow.js, like it's actually very little code, and it's super easy to set up. All you have to do is write a web page, and then you do like the things that you would expect to do on deep learning, right? And again, this is not like a deep learning talk, but like like basically these are the steps, and like you define your model, you load the model, like as inputs, you define your outputs, you specify, like the optimizer, like the loss function, and then you let it train, or you download a pre-trained model. So it's all there. And the really cool thing is like, if you copy paste this in your browser, it will work, right? So that's also pretty cool. And then, like, again, resources, it's, I mentioned Gans Laborde's book, it's Learning TensorFlow.js with O'Reilly, but there's machine learning with JavaScript, practicing machine learning, and a bunch of others. And the really cool thing is that this community is really just nascent, and it's ready for your listeners to be part of, right? Like all these books were written on the last 2 years, and so again, like it just right now, like no one knows about it, but it's really awesome that you're aware of this space, and you invited us to talk to here with you here, because this is ready. The resources are ready. What's missing is the motivation and people to like explore it and build solutions and grow in this environment. And yeah, just to show you one of the cooler apps that we have. And again, we haven't even mentioned what Hal9 is, but here we're doing image classification in the browser, like for these particular images, right, that I pulled from Imager. And they're not perfect. It's using ImageNet, a pre-trained ImageNet. But like you're running them in the browser with TensorFlow.js, and there's a bunch of other resources. You don't need to use Hal9 or use our examples. If you go to TF Hub, or like if you search TensorFlow.js image classification, you'll arrive to something similar. But the really powerful thing is that you can do all those things on the browser, and it's pretty cool. And then talking a little bit about use cases, and perhaps kind of like more closer to what we're doing, we've identified at least 3 of them. But there's definitely probably more, and we can talk about them. So the first one is, I use this example as a joke. I don't see Tesla using JavaScript to do full self-driving today. I don't know what they use, but probably Python with like custom, I think they use custom hardware for inference and whatever. So yes, this is just, this is not a use case. You probably don't want to do a full self-driving car unless you're learning, right? And then for, if you're giving a class and you want to do it, that's a different case. But the first use case is, and I think you mentioned it, Noah, that if you build a single page application, you're actually not paying cloud compute, right? Like everything is running on the browser, and it's fast, it's efficient, and it's just there available in the browser. So it's really like a great tool for for building very cost-effective dashboards or web applications. We were having a discussion early in the morning this morning today at Hal9, like what is a dashboard? And I think we arrived to the definition of like a dashboard is a subset of a web application that tends to be not dynamic, right? And I don't know, we can probably talk about this for a really long time, but like to your point, Noah, like this is pretty pretty awesome because it runs on the browser, it's cost effective, it's fast, and like it's a great use case, right? So I don't know if you want to do some brainwashing to your listeners here, because it sounds like you're a big believer of this use case.
Yeah, I mean, like I've used when our Shiny came out, like I used it in production. We used that as like a data visualization tool for machine learning systems. This was 2000 maybe 13, something like that. And there's some nice things about tools like Shiny, but the problem is they're just very inefficient. And then same with things like Plotly or Dash, or that it, yeah, to your point, like it's not real time.
Yeah.
And so what is nice about a pure JavaScript type solution is that you can actually build actually interactive visualizations.
Yeah, no, completely agree. And actually, I don't know if you noticed, but I'll see if I can find the tweet just on the spot. But there is I'm trying to look at the actual. So there was an announcement actually. I don't know when you're gonna make this public, so it's not gonna be yesterday. But the announcement was actually yesterday that they're porting Shiny to the Python community, and they have a demo using Shiny with WebAssembly. So let me see if I can find it. But like I'm Shiny Live. I think actually it might be shiny.rstudio.com/pi maybe. So they have a demo where I'm clicking examples, and you see here it running, and the first problem is like it takes a little bit of time to load, and I have like a Starlink connection that is super fast, but like like when you use WebAssembly and when you bring up Python completely, if you import any if you import pandas, right, or whatever, you're the Python expert. How do I import pandas? Because I'm more of
import pandas as PD.
Yeah, I know you know that. So for memory, but yeah, when you do things like this, you're downloading up to 60 megabytes, and like things get clunky and takes time, right? So and it's not just Shiny that is doing that. Like there's a project called PyScript from Anaconda that uses Pyodide compiling the browser. But yeah, to me really, I don't know if we can really scale with tools like Pyodide on the long term, because like people already complain that websites are already heavy with like 3 megabytes, I think is the average. And this pushes us all the way to at the very least 10, if not 30, if not 60 megabytes per download. And anyways, maybe it's the future, and maybe I'm wrong. But I think without talking about the specific technologies, what I would say is that yes, like the difference between running any of these frameworks on the server versus running them on the browser is huge and has like a lot of cost efficiency and whatnot. And yeah, we can try to wrap up, but like well, actually, let me just show you one demo that I'm super excited about, because so what we're doing at Hal9 is we're building basically we're building the applications natively with JavaScript, and we're building a Python and an R package as well, just to mostly to help people get onboarded, because it's gonna take some time to do the transition. Although I would argue that you should be a rebel and become like an expert on data science with JavaScript. But basically the demo that we have is like you're able to build with the Hal9 package a web application using either Python or R, using some constructs, right? And a spoiler alert, the constructs behind this are using things like Archero.js that we discussed, are using things like D3 that we discussed, etc. Right? And yeah, what is the benefit? Well, like first of all, like the download size of the Hal9 library is like something like like 0.1 megabyte instead of like almost 60 megabytes. And the other one is interactivity, right? Like you see a slider and it's like super fast, because again, like you're running everything on the browser. And again, I don't want this to be an advertising for using Hal9. It's more like you should definitely use JavaScript and consider it when you're building your web applications, right? Like that to me is the most important thing. And a couple other use cases, like if you already work in a company that uses Node.js and React Native, or, like all these technologies as their tech stack. To your point, like, why would you waste time trying to duplicate your stack on deployment and, like all these things? Like, that's super tricky. Like, why wouldn't you ask your data scientist, hey, write your data science in JavaScript, and then it's compatible with all our engineering infrastructure. We know how to deploy, we can maintain it, we can help you, like, you already have a team of experts, right? So that's the second use case, and applies more to companies that are already in that space. And the third one, and maybe my favorite, is, I don't know if you know this, Noah, but SpaceX built their Dragon capsule UI with JavaScript and HTML. I don't know if you were aware of that, but like, on their Reddit AMA, like the SpaceX team basically was explaining, we're using HTML and JavaScript. And why are they using that? Is because it's the best, most deployable, most reliable application framework that we have today, right? And so I do believe if you have something super advanced, like, you might want to offload, you might still want to do some computation on the server, but, like, if you're building, like a spaceship or a car, you might not want to have the data science model that predicts when you are going to arrive on the same GPU that is running inference for driving the car, right? Because if there's a bug there, that's really bad, right? So, I still think that, kind of like really state-of-the-art advanced user interfaces, that's a great use case for using, like data science and AI and machine learning with JavaScript. And, like, we see companies like SpaceX doing them. Honestly, if you want to learn more about it, go to Hal9.com. Right now, we're in an uncomfortable transition period where we closed off a little bit our invites, and, we're planning to, relaunch, mostly because, we learn a lot from reaching out to the community. We know that they want an open source project. So we're rewriting, cleaning up the code. So if you go to the webpage today, it looks a little bit lonely, in the sense that, like, it's just kind of like a landing page, but I can give you the secret URL and you can post it there, which is hal9.com/gallery. And there's more of a preview there that you can use to actually, look at the site and the tools that we're building. Let me see. But yeah, I don't know, Noah, if you have any questions or anything else that we might have missed.
Yeah, I think your idea is an interesting idea. In the for if you're targeting especially people who are serious about performance and doing especially high performant real-time data visualization, then I think there's something to be said for this. And I also think the ability to actually do stuff inside of a browser is actually, like, either train a model or take a pre-existing model. I mean, my suggestion would be to heavily use pre-trained models in your products, because I suspect what we're going to see is like an explosion of people taking pre-trained models and putting them into systems, because I suspect that there's going to be less people training models in, let's say, 5 years. And I would say it could be 80-20, where 80% of people that do ML, they're not actually training anything, and they never want to train it, because just like we do with other things, we just take we just take something that works and we plug it in. That's what a software developer does. But yeah, I think there's a lot of interesting things here that you showed, and I think a lot of people on O'Reilly would be very interested in hearing more. And yeah, I'm going to upload this in, let's say, under a week or so, and I'm sure people will reach out to you.
That's awesome. Well, that gives us a deadline such that when they look at the video, they see the new webpage. And, like, I love deadlines because it forces you to get stuff done. But yeah, thank you so much for having us. And I think I might have one more slide here that we can leave. Just, it's this one, I guess. Yeah, just feel free to contact us. It's Pedro at Hal9.ai or Javier at Hal9.ai. And yeah, super happy. Honestly, like, the community is pretty small. And, I'm looking forward to hear feedback and, get people excited. I think there's a lot of opportunity here. And if you ask me, I think there is a possibility that this is the future of machine learning and artificial intelligence, but that's just me.
Well,
and, yeah.
I mean, the part that where you could have a point is, if we do head towards mostly pre-trained models, which here's a good point, like, how many people are going to be training NLP models at the scale of Google,
no one.
Meta? Nobody, right? So
no one.
What are you going to do? Why would you build a worse one? Why wouldn't you just use the one that works? And so if that is the case, which I suspect it could be the case, then now JavaScript becomes a lot more interesting because basically you have made the case so obvious for people to use JavaScript because all you have to do is just use it inside the browser. So I think that could be one of the stealth wins. The one question I did have though, real quick, was I know that right now there's PyTorch and TensorFlow. I happen to lean a little more towards I like TensorFlow more because I don't like Meta, the company.
Yeah, sure. Yeah.
And I'm just kind of I'm for democracy. Like let's so but TensorFlow I heard is shifting to JAX. Yeah. So what do you have any thoughts?
Yeah. So actually there's a GitHub issue open where people are begging to the PyTorch community is like, hey, can you port this to JavaScript, right? And their answer, but maybe it's a good answer because you just taught me something. The answer is like, no, we're not doing that. Maybe someone else can do it. But they do recommend using Onyx.js. So Onyx.js is this framework, a JavaScript framework to run. Basically, well, it's not a JavaScript framework. It's a generic model framework that allows you to convert models from TensorFlow and PyTorch and Scikit and all of these different things into a common framework, and there's a port of that on JavaScript, right? So maybe that's more of the future because you can't train the model on PyTorch and then convert it to Onyx and then run it on the browser. So that was their answer. So their answer is like kind of like agreeing with you. Is like, well, why do you want to do the training? Just kind of like use Onyx, JavaScript, and like you're there.
I'm actually very familiar with Onyx, and I've used it quite a bit. And I didn't know that there was a JavaScript Onyx, and that the fact that, I mean, here's another scenario that's kind of interesting too, is that with Apple now and the new chips that they have, you can click a button and use Create ML. I don't know if you've ever used that before, but like
I haven't. I've just seen it.
You can literally take like a directory full of images and just drop it onto their GUI tool, and because they have like super fast, the studio processor and all this stuff, you'll train a model that's huge. Like it's like just like this. You can export that model as Core ML. You can, I believe, convert it right into Onyx, and then you could take that and then use your technology to actually just visualize it.
Awesome.
So you could actually kind of even encourage people that we're going to train their model. Hey, why even write the code? Just use an off-the-shelf tool like that comes free with your Mac, train it, convert it to Onyx, and then you could run it on Hal9.
Yeah, that's pretty awesome. I mean, I'm so glad to find people like you, Noah, that are excited about this, because it is so cool to find people that are excited. And I feel like you just created a company here, right? Like, so if someone can solve just that particular problem, right? Like you give the PyTorch model and gives you an Onyx model, and maybe there's someone already doing that, but that's a tool that is needed, right? And I think my biggest point to make in this talk is like, this space is super exciting, and there's so much opportunity that anyone that wants to get involved, like they're probably gonna find it very rewarding, and to help the community and move things forward. So thank you so much for having us, Noah.
Yeah, thank you so much, and we had so much fun. We even went over time.
Sure. Yeah.
Okay.
Sure. Thanks, Noah.